Here are a few more challenging limits from in your notes that we didn't get to in class. You guys said you'd rather have a video. So again, when we're doing the limits, as always, you would attempt to put the value that you're approaching in for x. In doing that on this one, you would end up getting 0 on the top and 0 on the bottom, which we've said requires some manipulation. And we've got our manipulation, all the different possibilities. We've tried factoring. We have tried multiplying by a conjugate when there's complex fractions. We've tried cleaning them up. We also had some trig rules. This one's got a complex fraction, so what we're going to do is clean up that numerator first. And again, the whole point of doing this is to simplify it in hopes of some canceling, in hopes of being able to put the 3 in and still have it not be 0 over 0. So what I've got here is the limit as x approaches 3, and I'm going to clean up the top part of that fraction, which would become 3 minus x over x. And that's all over x squared minus 9. And you should recognize that difference of squares down there in the bottom of the fraction, which we are also going to be cleaning up. This gives us the limit as x approaches 3 of 3 minus x over x. And then you can either picture multiplying by the reciprocal, which would be 1 over x squared minus 9, or we've done these enough where this just ends up on the bottom of the fraction. You divide it by it, so it ends up down here. Then what I should notice with this one, and notice I'm not dropping my limits, I'm keeping nice proper notation going through here. I've got my limit as I approach 3 of 3 minus x all over x times, and then I'm factoring. Now right here, the whole reason we cleaned up the top of that fraction is because right here I've got on the top 3 minus x, and on the bottom I've got x minus 3. Those are opposites, so these cancel to leave a negative 1 on the top. This is good because I'm eliminating my 0 over 0 indeterminate form by doing that. So I end up with a negative 1 over x times x plus 3. So now what I want to do is go see what happens when I put 3 in this time. And you'll notice I end up getting 3 times 3 plus 3, or 3 times 6. So my limit is negative 1 over 18. If you were to graph the original function, you would notice a couple things happening. First of all, you would have to, graph it in your standard window, but in order to see what's happening in there around 3, you would need to zoom in. When you zoom in there, you're going to see that it's approaching negative 1 over 18. However, remember, because we canceled this factor, there's really a hole in the graph which your calculator won't show. I'm not going to go graph it. Our limit as x approaches 3 is negative 1/18 for that one. With these absolute value ones, again, you need to be really careful, but first thing I would do is try putting in the 3, and I'm going to get a 0 over 0. The next thing I attempt to do is factor. So I'll notice on the top, the first thing I'm going to do, and again, I'm approaching 3 from the right-hand side on this one, is I've got the negative, and I'm going to try to factor that top. So I'm going to do a 2x and an x, creating that 2x squared. Now, I'm going to need to end in a 3 and 1, which means my 3 will have to be on the outside so I can get that 6, and then a 1 on the inside. Because I'm balancing out negative, I'm going to want to have that minus 6 on the outside and the plus 1 on the inside. You might again want to refoil that to make sure you have it right. Now on the bottom, you've got to be careful with the absolute value.
Tyler Island, please report to Mr. Goldholm.
Sometimes. So
Tyler Island, please
the
report to
absolute
Mr.
value of
Goldholm.
3 minus x is either itself, the absolute value of anything is either itself or the opposite of itself. For example, the absolute value of 7 is simply 7. It's itself. But the absolute value of negative 7 is actually the opposite of itself. So you've got to be really careful down in here that you understand that formal definition of the limit. That it's itself when it's positive and the opposite of itself when it's negative. So you've got to creep in here on the right of 3 and see if this 3 minus x is positive, in which case you can just drop the absolute value bars. Absolute value of 7 is 7. The bars aren't really doing anything. Or, if what's under there is negative, then again I have to say, well, it's the opposite of that. So when I creep in from the right of 3, so I'm thinking 4, maybe 5, 6, or even really close in at 3.00001, this under or inside the absolute value bars goes negative, which means when it goes negative, I have to take the opposite of it to evaluate it. So really what I've got under there is the opposite of 3 minus x when I come in from the right. You can even try it with a number, watch. So let's go way to the right, like at 7. I would say, well, that is negative 4, absolute value of which is 4. Notice I got the opposite of 3 minus 7, which would be the opposite of negative 4, which is 4. So just so you understand, I think when they first teach absolute value, they say, it's always positive. It's distance from 0. But here, we really need to understand the formal definition of it. Now, I've got a negative over a negative, which makes a positive. However, I've also got another pair of opposites here with the x minus 3 and the 3 minus x, which leaves a negative 1. So, when I'm all done with this, I'm really taking the limit as x approaches 3 from the positive side of negative 2x plus 1, because I had that negative 1 in there. Now when I go plug it in, I'm going to get a negative 7. Now, the next one seems a lot like it. However, down here with the next one, it's starting with the same process. I've got the same numerator, so I'm going to have the same factoring going in on the top. But just so you can see what the difference is, it matters what side you're creeping in from. On this
I was called Joan at 2140, please.
That's a problem
call
in
Joan
making
at
after school.
2140.
So on this one, I'm creeping in from the left. So again, I have to go to the left of 3. I could go way out, like negative 7. Well, 3 minus negative 7 is just 10. I don't really need those absolute value bars because really when I come in from the left, I get a positive value in here. Even if I get really close, like 2.9999, when I subtract that from 3, it's still positive. So the absolute value of 3 minus x when I'm coming in from the left is just itself. So you really do need to do a little creeping in there to see whether you keep it like I did in this one or whether I take the opposite like I did in this one. So the difference in the answers for this is I still have this negative out front. These two, oh my gosh, I'm sorry. And that gives me another negative 1.
Mrs. Altavilla, extension 2145.
Alright, so on this one, my negative times my negative gives me a positive. And again, I've dropped my limit, which I told you to be careful not to do. I'm approaching 3 from the left. In this one, I'm taking the limit as I approach 3 from the left. Now I can just plug that in and I get a positive 7. So note the difference in the answers. You've got to be very careful with that absolute value. Now, what does this tell me overall? I would tell you this, that if the question had been what's the limit as x approaches 3, and I didn't have the positive on it like I did here or the negative on it like I did here, I'm just going to call that f of x just so I don't have to rewrite it again, I would say that does not exist. And if I had to defend my answer, remember we have 3 situations in which a limit fails to exist. When it oscillates, when it increases or decreases without bound, or when the limit as I approach from the left does not equal the limit as I approach from the right. What that implies about the graph is that I'm going to have a negative 7 and a 7, which is going to cause that in my graph. I'm going to have a big old gap going on, but you can't say gap. So if I had to, again, I did put this on here, but had I said, well, what happens as I approach 3, which means from both directions, you'd say that limit doesn't exist. And if I said, give me a reason, don't tell me there's a gap, don't say something like, it's not the same. You say, either you write a full sentence and you say, because the limit as I approach 3 from the left does not equal the limit as I approach 3 from the right, or you use correct symbolic notation. And you say the limit as I approach 3 from the left of f of x, which equals negative 7, did not equal the limit as I approach 3 from the right of f of x, which equaled positive 7. And again, I didn't ask you this part down here, but it's a good extension question on that. So, that's all. We'll see you later.